Ever built an AI assistant that forgets everything between conversations, forcing users to repeat themselves constantly? You'll see how to create persistent user memories that survive across different chat threads. We'll use a simple in-memory store to save and retrieve user preferences, then make them available to any conversation with that user, no matter how many threads they start.
Memory extrude, UUID 4. Memory equals food preference. I like pizza. In memory store, put namespace for memory, memoryid memory.
This demonstrates the externalized state pattern for persistent memory management. The concept separates transient execution state from durable user-specific data, using namespace storage to maintain context across multiple interactions. What makes this distinctive is its ability to persist arbitrary data structures beyond just conversation history, enabling true cross-session memory without coupling to any specific workflow. The pattern works by decoupling storage concerns from execution logic through two complementary systems: checkpointers for thread-specific state and stores for user-scoped memory. Checkpointers handle the temporal state of individual workflows, while stores provide a key-value interface for durable, queryable data that persists beyond any single execution. This separation allows for independent scaling of execution history and long-term memory systems. This approach solves the problem of statelessness in distributed systems while avoiding monolithic session storage. It's particularly valuable for conversational agents, personalized workflows, or any system requiring both execution history and persistent user context. The trade-off is increased infrastructure complexity, but the clean separation of concerns makes the system more maintainable than alternatives that conflate execution state with user data. Let's break it down line by line.
Memory extrude, UUID 4.
Generates a unique identifier using UUID version 4, then converts it to a string. This ensures a globally unique memoryid for tracking individual memory instances, preventing collisions in distributed systems.
Memory equals food preference. I like pizza.
Initializes a memory dictionary with a key-value pair. This serves as the initial state for the memory store, providing a concrete example of structured data that will be persisted under the generated UUID.
In memory store, put namespace for memory, memoryid memory.
Stores the memory object in the in-memory key-value store using the generated UUID as the key. The namespace parameter prevents collisions between different memory contexts, enabling isolated storage for separate sessions or users. Memory management in LangGraph. The memoryid and memory pattern demonstrates how LangGraph organizes persistent data using unique identifiers within namespace stores, enabling both direct retrieval and semantic search capabilities. UUID generation for memoryid ensures collision resistance, but remember that namespaces must be consistently structured to avoid retrieval failures across different contexts. This approach decouples memory storage from execution state, making it reusable across threads and sessions while maintaining isolation through namespacing.
The namespace that divides creates the only whole.